Good morning, Chem 20s. Our lesson today is going to be on how to prepare a standard solution by dilution. What we're going to do is we know that dilution is rather easy to do. It really involves just adding water to decrease the concentration of our original solution. However, to make a stock solution, usually we start with a concentrated solution and we add a very specific amount of water, a very precise amount of water in order to create this dilution. What we're going to do is we're going to take the copper 2 sulfate pentahydrate that we created from a solid in a previous demonstration video, and we are going to dilute it from 0.186 moles per liter, and we're going to make 100 milliliters of 0.0186 moles per liter of this diluted solution. If you would follow the provided link at the bottom of this video, it will take you to the dilution demonstration. All right, so let's get started here. Again, as always, we're going to make our list of variables. So I have my initial concentration of 0.186 moles per liter. We are going to have to figure out what is my volume I'm going to have to dilute down. My final volume is going to be 100 milliliters. And my final concentration when I dilute it is going to be 0.0186 moles per liter. So looking at my units will cancel perfectly. My answer I'm going to get out in my calculator is going to be in milliliters. So my formula is still C1V1 equals C2V2. We are going to solve for V1. So we're going to move C1 to the denominator. So to find the initial volume, we're going to take the final concentration, multiply it by the final volume, divided by the initial concentration. So we're going to take 0.0186 moles per liter, and we're going to multiply it by 100 milliliters. Then we're going to go ahead and we're going to divide it by 0.186 moles per liter. So when I go to calculate this, 0.0186 times 100, enter, divided by 0.186, and my answer is going to come out in 10.0 milliliters. So that's the initial volume I'm going to have to measure out and then add water to it in order to get it to 100 milliliters. Now, in the lab, it's a little bit more complicated than that. So let's take a look at the equipment we're going to need. In order to prepare this solution by dilution, I'm going to need, of course, my copper 2 sulfate solution that we had. I'm going to need a beaker, some distilled water, a 10 milliliter pipette, 100 milliliter volumetric flask, and of course an eyedropper. Again, this link to how would you prepare this solution or watching me prepare this solution will be in the description below. For right now, I'm just going to go through the steps though on paper. So step number 1, since we are making 100 mils of the solution, we are going to add 50 mils of distilled water to a 100 milliliter volumetric flask. We always add approximately half the amount of the final volume in water first. Then what we're going to do is we're going to take a pipette. And there's two types of pipettes. There's volumetric pipettes, which you'll see has this little kind of bump in the middle. And then there's graduated pipettes that don't have that bump. The difference between the two is in a volumetric pipette, and in our case, a 10 milliliter volumetric pipette, when you pull up solution or when you suck up solution with the bulb, there's only one calibration line. This pipette only transfers 10 milliliters of solution. So I'm going to suck up until the meniscus is on the calibration line. I'm then going to transfer this over to my beaker or container, whatever I'm using, and I'm going to let go, and I'm going to let gravity pull the liquid down. Again, at no stage do I do anything more than let the gravity pull it down. Again, we're going to watch for splashing, but if we kind of tilt it and pour it at its side when we're doing this, then we won't have any splash problems. The other type of pipette would be the graduated pipette. This one has more readings on it, so I can measure many different volumes on a graduated pipette. Again, for 10 mils, I'm going to suck up solution. I'm going to get it so the bottom of the meniscus is on the 0. I'm then going to transfer it over, and I'm going to roll my finger to run my solution down. I'm going to go slowly, and then I'm going to have to stop again at the bottom. Unlike in a volumetric where I let it run till it stops, in a graduated pipette, I am measuring this. So I'm starting at 0, and when I want 10, I have to stop it again so the bottom of the meniscus is at the 10 milliliter mark. The little bit of solution that's still in the tip of the pipette, it does not get transferred. We put it back into my starting beaker. So I am pipetting 10 milliliters of my initial concentration of the copper 2 sulfate, the 0.186 moles per liter, and I'm going to pipette that into the volumetric flask following the water. So I started with water. I then pipette 10 milliliters over, and I'm going to sandwich it water, then copper 2 sulfate. The third step is, now that I have my two solutions in here, my water and my copper 2 sulfate, I'm going to do like I did making my solution from a solid. I'm going to take some distilled water, I'm going to take an eyedropper, and I'm going to get down at eye level, and I'm going to keep adding drops of distilled water until the bottom of the meniscus is on the 100 milliliter calibration line. Last but not least, I'm going to, if I need to tap out any bubbles, I will do that. I'm going to put the cap on. I'm going to invert it several times and let the natural air bubble mix my solution. When we do a dilution, we are always adding first approximately half the amount of the final volume in water. We're going to add the appropriate initial volume of stock solution. Then we're again going to fill up to the calibration line on water. So it's a water, stock, water solution, if you want to remember it that way. Please go now, look at the bottom, and follow the link to the dilution demonstration.